Hello, hello. Tell me once if my voice is clear to all of you. So that we can start. So that we can start. Yeah, voice is clear. Fine. Namaskar, Adab, Sat Sri Akal. कैसे हो बच्चों? How are you all? I hope that all of you are doing very good in your studies. Okay. So we were studying about wave optics. Okay, I've told you that wave optics is completely connected chapter. So if you have not watched the first two lectures, then you will not understand anything in this third lecture also. So firstly, what you have to do, you have to understand the first two lectures and then come to the lecture. Okay. Today also we are going to see some portions of YDSA. I was explaining you about the fringe pattern that was forming on the screen. Young's experiment that we have performed, two thin slits we have taken, distances we have measured, angles we have calculated, how part difference we have written, all these things we have calculated in the last lecture. Major YDSA is completed there. Now we are just going to take some little bit left portions from there, okay, and then we are going to start diffraction. Then we will be entering into the diffraction portion. Correct? Fine. So let's start without wasting any further time. Be ready with your pen and paper, okay, and be excited to learn something new. Something very excited is going to come always in physics. It is not like other subjects. I will not say anything that other subjects are boring. Still, I feel that physics is the most interesting. So always we should be excited to learn something new. Okay. So let's understand again. I am going to connect you with the last lecture in briefly. Okay, what was the setup and how the experiment was going on? What were the results that were coming? Okay, very good. What was the setup? If I will tell you, we have firstly taken two coherent sources, and for making coherent sources, what we have did, we have taken two slits S1 and S2. Actually, they were not two sources; they were actually two thin slits which were behaving like a two sources. That means light was coming from here also, I'm coming from here also. This distance was written as small d. This distance between the screen and the slits is given as capital D. Okay, and light wire was interfering at all the points, and with that interference we have decided something. If part difference is equals to going to be zero part difference means we have named this position as central maxima. We have named this position as central maxima. Then what we have observed, we will have part difference is equals to lambda by 2, and we have named this point as first minima. We have generated all the conditions of maxima and minima. Then we have got some point, part difference is equals to lambda. We have named this as, it was first maxima. It was first maxima. Then again 3 lambda by 2, then again 2 lambda, and same again in this case also. In here also part difference will be lambda by 2. It will be again first minima in downward direction, symmetrically, complete symmetrically. Then there will be a point, part difference is equal to lambda, and here also, so it will be called as what? First maximum. All these things we have understood. Correct? Now see, what I am asking you, tell me, what was the distances we have written? Why? Let's suppose if I will ask you the distance of this, distance of first maxima, how you have written? If you remember, we have written it is equals to n d lambda by d. This is for position of maxima. So if I will ask you, beta, tell me what is the position of first maxima? Position of first maxima, you will put n is equals to 0. You will put n is equals to 0. N is equals to 0, you will put what you will get as y, position of first maxima, the first one, and actually we call it as central maxima. It is a point of maxima, correct? Now put y is equals to 2. Firstly n is equals to 0, then y n is equals to 1. N is equals to, where y you will be writing n is equals to 1, here you have put it n is equals to 0. Y is equals to n is equals to 1. What you will get? The distance you will get d lambda by d. Okay, now put y, if I will ask you about second maxima, that means n is equals to 2. This is the first maxima, second maxima. Now third maxima you will get, that is equals to 2 d lambda by d. This you will keep writing. And one more shortcut, if I will tell you after some time. Same way write for minimas as well. If I will ask you the position of minima, how you have written? You have written, sir, it is equals to 2n plus 1 lambda by 2 d lambda by 2d, correct? This way you have written in general. So if I will ask you, tell me the position for first minima. If I will ask you the position for first minima, how you will be writing, I will tell you better method to write it. Okay, that's why I'm just concluding everything. And I told you this will be behaving like a bright spot, then dark spot, then again bright spot, then again dark spot. These kind of things we have discussed in the last lecture. If I'll ask you about the first minima, then what you'll be doing? First minima, put 0, n is equal to 0. That means you will get what? D lambda divided by 2d. Then second minima, how will you calculating? Put n is equals to 1, n is equals to 1. That means it will become 3d lambda divided by 2d. This way second minima will be coming. So that means this way you will be writing the distances. Is it clear? Okay, just I have put it the n values and I have calculated the things. Any problem? Correct. Now what I will tell you, there is a term fringe width. What is the term? Fringe width. These are the fringes, bright fringe, dark fringe. These are the fringes. And the distance between two consecutive maximas, either two consecutive minimas, is called as fringe width. Simple definition, represented as beta. What is the representation? Beta. If I will tell you, tell me the distance between first maxima and second maxima, or zeroth maxima, central maxima you can call zeroth maxima and first maxima. If I will ask you the difference, what is the distance between them? Can you say distance between them will be y1 minus y0, that will be equal to d lambda by d. Can you say it is what? The width. Now notice a pattern. If I'll ask you the distance between first maxima and second maxima, what you will say? Distance between first maxima and second maxima. Differentiate. Now take the difference y2 minus y1. When you will be taking the difference, can you say again you will be having the same difference d lambda by small d. Again you have the same difference. Minima. In case of minima, take the difference between the first minima and the second minima. Just you have to take the difference. Y2 minus y1. What will the difference will be coming? 3d lambda minus d lambda, that means 2d lambda by d. Can I say again you will have what? D lambda by d. So what is the difference that is common in all these cases? I can say fringe width, that is represented as the formula that you have to remember. Fringe width, spelling is this, fringe width represented as beta is equals to d lambda divided by small d. Fringe width is equal to d lambda divided by small d. You can see at every distance, any maxima you can take consecutive maximas. Third maxima, fourth maxima, fifth maxima. This kind of consecutive maxima, either minima. When you are taking the difference in YTSA experiment, always you will have the distance d lambda by d, that is also defined as fringe width. Is it clear? Correct? Fine. Any problem? Okay. So this is what here it is completely explained. Again, the same kind of things will be explained. Say here the distance, this is the central maxima, then d lambda by d, 2d lambda by d, this is the dark spot. So in diagram form also it is explained. Okay, so here it is for your reference. And finally fringe width will be coming, that is equals to d lambda by d. Is it clear? Now there is a one more term, but more oftenly you will be having fringe width as d lambda by d. One more thing I will tell you, very important. Okay, here here only I will tell you. Always remember one thing, one shortcut I am telling you, how to write the position of maxima. Otherwise you will be confused a lot. Basic thing, but for removing the confusion, I am telling you a method. If you have to write in general maxima position, if you want to write, just write n beta. That's it. Just remember n beta. What is beta? That you already know. In any question, always calculate beta first. It will become what? N d lambda by d, and exactly this was the formula. So is there anything special? No. Maxima is not that much special, but remember in n beta, it will make the question easy. But in minima, remember one thing. Always write n minus half beta. N minus half beta, where n is equals to 1, 2, 3 and so on, not 0. When you are putting 0, it will become minus. That is also the correct distance, but because in downward direction you will be taking that as negative. But as of now I am telling you, same if you are going in positive direction, it is symmetric in the negative direction also, so you can apply your common sense. So what are kind of positions you will get for minima? First, n is equals to 1, that means it will become half of beta, that means d lambda divided by 2d, the first position of minima, and we know exactly that this is the position of first minima. Then put n is equals to 2, that means it will become 3d lambda divided by 2d, then 5d lambda divided by 2D. So this way you will go for minimas, and this way you will go for maximas. 0, d lambda by d, 2d lambda by d. So this way it will become little bit easier for you to writing the maximas and the minimas. Correct? First minima, for first minima, what we'll be doing, n is equals to 1 in minima, and for first maxima, it is always the central maxima, or also you can call it 0th maxima. For first maxima, here also n is equals to 1, you will have the first maxima. And central maxima is, you can consider as 0th maxima, so that you can remove the confusions that you will be having. That's it. Nothing more than that. Or if you are comfortable in the conventional method, sir, I will be writing the complete formula. It's up to you. But always remember in terms of beta, because the questions will always be comfortably calculated. Once you have calculated beta, then the questions will become very easy. It will take a lot of lesser time. Okay, that's why I told you. Now it's your choice. See, now there is a term angular fringe width. In terms of angle, in terms of distance, we have seen that what is the distance between two consecutive maximas and two consecutive minima. But what if I have to check the angles? The angle between two consecutive maxima or two consecutive minima. Let's see what is the angles that are coming. See, for any in general position of maximum, what is the distance you write? N d lambda by d. For any, let's suppose this point is maxima, so you have written n d lambda by d as the position of y. If I will ask you define tan of theta beta, what you will be defining? You will be writing, sir, it is equals to y divided by capital Y divided by d. Correct? Correct. So I know that this theta is very small. That's why what I can write, if this theta is very small, I can write directly it as theta. Okay, and theta is equals to y. Y is equals to what? You just know for maxima it is equals to n d lambda divided by d, and it is already divided by d. D will get cancelled, and here it will be left n lambda divided by small d. N lambda divided by small d. Now, if I will ask you for first maxima, it will become 0. Theta is equals to 0. You know, for central maxima, theta will be equals to 0. For first maxima, what you will be writing? N is equals to 1. That means lambda by d. For second maxima, what you will be writing? 2 lambda by d, and so on you will be proceeding. So if I'll ask you, tell me the distance between two consecutive maximas or any consecutive two maximas, you will be getting here also lambda by 2 and here also lambda by 2. So what I can define as angular fringe width? Angular fringe width can be defined as simply lambda by d. Remember the formula, okay, basic thing. So it will be defined as lambda by d. Correct? In minimas also, if you want to check, Carlo check. Here also the same results will be coming. Let's cross check it also. What you can do. See, in general, what you write for position of minima? 2n minus 1 d lambda by 2d. Now it depends at. See, you can go conventionally also, putting 2n plus 1. I will say, if from my conventions you are going to write it 2n plus 1 d 2d lambda by d. Okay, divided by 2d. But a lot of places it is also given in terms of 2n minus 1 d lambda divided by 2d. So nothing is wrong. You can take this also. But you have to just consider that which one is giving you the position of correct first minima and second minimum. For example, in general position, let's suppose it is given like this. Okay, there is no problem into that also. How you will be writing? What is tan of theta? Again you will say, sir, it is same. That is y divided by d. That means again you will be writing and it will be get cancelled. That means in general kya raha? 2n minus 1 lambda divided by 2d, and I can write this is nothing but n theta, because theta, tan theta is very small. That's why I can write it as theta. Now put n is equals to 1. N is equals to 1 when you are putting, it will become lambda divided by 2d. Put n is equals to 2. N is equals to 2 when you are putting, it will become 4 minus, it will become 3 lambda divided by 2d. Correct? These are the angles of first. This is first minima, this is for second minima. Now take the difference. That is what exactly going to give you the angular fringe width. Correct? So if you are calculating the angular fringe width, just simply take the difference. When you are taking this difference, it will become how much? It will become again lambda by 2. And can I say it was exactly the last result also? Isn't it? For maxima positions, when we have calculated angular fringe width, it was coming the same lambda by d. And for minima also, just we have cross checked. Otherwise we know that it is completely symmetric. It is also going to be same, because in fringe width also you have checked that normal fringe width was coming same either for maxima consecutively two maximas, either consecutively two minimas. Angular fringe width also it is going to be same either for two consecutive maxima or either two consecutive minima. That's it. This is what we have to just understand. So just remember the direct formula. It will be sufficient for you to solving any kind of question. Now let's discuss a little bit about intensities. What kind of intensity pattern, how much the light intensity is coming at the first maxima, minima, or the second maxima, second minima. Sir, if central maxima is the most brightest, if it's like that, then why? All these things we are going to understand just by understanding one simple thing. From SHM, you are studying about waves. And if I will ask you a simple thing, tell me the relation between intensity and amplitude. What is the relation between intensity and amplitude? If I will ask you this simple question, all of you should be remembering from SHM only, from the last year, you are studying that intensity is directly proportional to A square. A square means what? Amplitude square. So now quickly go into the recap a little bit. If you, I have told you, when you are doing superposition, you got a new third wave, and that third wave resultant was given like what? What was the formula? If I am writing A square of resultant square, you can write it as A1 square plus A2 square plus 2A1 A2 cos of phi. Correct? This is what you can write. So if I'll ask you, tell me the resultant intensity at any position, how you will be writing? If I have to write the intensity at any position, how I will be writing? Correct? This is the question. So I know that intensity is directly proportional to A square. So I will write at the place of A resultant square, I will write I. At the place of A1 square, I will write I1 plus I2 plus 2 root I1 root I2 cos of phi. This is what the in general equation you will be writing for intensity at any general point. Correct? अब ये मत पूछना यार कि how it will become I1 I2 and 2 root I1 I2. I hope that इतना तो clear होगा. Okay, ऐसा doubt तो मत पूछना please. कोई है यार? Still anyone that have doubts, sir, how you have written this one? I know that a lot of will be there. And this is simple here. This will be expected. Fine. Now, and what kind of scenario we are tackling with? We are tackling with coherent sources. Coherent sources, correct? Let's suppose if I will say that intensities are same for both the lights, because it is coming from the same source. That means intensity of both the sources S1 and S2, same light is coming here, so sources will be same also. So if the case is that, so what I will write, that I2 is equals to I1 is equals to, let's suppose, I. So what I can say for I resultant I can write, it will become 2I plus of 2 I, it will become 2I cos of phi. It will become cos of phi. Now take 2I common, what will be left? 1 plus cos of phi. अब बताओ, what you can write for 1 plus cos of phi? It will become 2 cos square phi by 2. That means finally you can say that resultant intensity is equals to nothing but 4I cos square phi by 2. This is what you are going to write. Resultant intensity will become, if I1 and I2 are equal, is equal to some I0 or I. If you are saying, that means it is going to be equals to 4I into cos square phi by 2. Correct? Now tell me, two kind of interference we have studied about. What are those two kind of interference? Firstly, we have studied about maximum, that means constructive interference, and second one we have studied about destructive interference. First one we have studied about constructive interference, second one we have studied about destructive interference. Now tell me, what was the value of cos phi in that case? What was constructive interference? Remember? Yaad karo. What was constructive interference? Amplitude is maximum is called as constructive interference. If amplitude maximum is called as constructive interference, how we have made the amplitude maximum? This was the amplitude. And how we have made it the maximum? I have said that cos phi is equals to maximum. What is the maximum value of cos phi? Cos phi is equals to 1. And at what angles for cos phi is equals to 1? That is the important thing. So I will say at 0 degree, at 360, that means at 0, 2 pi, 4 pi, this kind of angles is going to give you cos phi is equals to 1. So let's put, if I am putting here 0, pi by 0 by 2, again it will become 0, cos of 0 will be equals to 1. That means what is the resultant intensity will be coming here? You will be saying, sir, cos phi is equals should be 1. That means phi should be equal to 0 degree. If I am putting phi is equals to 0 degree, resultant intensity at bright positions is equals to 4I. This is what the result I am going. I will plot this complete graph also. You will be seeing that what kind of graph that we are going to get. Okay, and that will be very obvious. The distances that will be measuring, it is completely proving the experiment. Second case, destructive interference. Now, what was the definition by convention? What was destructive interference? When the amplitude is minimum. How you made the amplitude minimum? Remember, you have made this cos phi as minimum. What is the minimum value of cos phi? Cos phi minimum value is -1, correct? So at what angles it was getting -1? At pi, 3 pi, 5 pi, 7 pi. All these angles were giving you how much? -1. So now just put, if we are putting the same something like cos phi is equals, should be equals to -1. That means phi is equal to, let's suppose, pi. So if we are putting here pi, that means it will become cos square pi by 2. Net it will become cos square pi by 2 when you are calculating the intensity. And what is cos of 90 degree? Cos of 90 degree is equals to 0. So can I say resultant intensity for destructive interference is equals to 0? That's why we call it as the dark spot, because the intensity of light that is reaching at the dark spot or the destructive interference is 0. There is no intensity, that means there will be no light. Correct? Everything is connected. So let's see what kind of plot that you will be having here. This is the plot. Intensity versus part difference. Part difference, in terms of part difference it is mentioned. When part difference is equal to 0, what we call this position? Central maxima. Central maxima part difference 0. What is that? It is a point of constructive interference. That means it is a point of maximum intensity. Here see, it is having the maximum intensity 400. Then again continuously intensity will decreasing. Part difference lambda by 2. Lambda by 2 part difference minima position. That means intensity will be 0. Again move forward. Same will be going on the other side also, symmetric. Move forward. What is the part difference? Lambda. Part difference lambda. Constructive interference. That means bright spot. Bright spot, that means what I can say? Again, intensity will be maximum. This is the plot of cos square 5 by 2. Cos square theta will be become coming above the negative axis. This is a little bit of math that you can ask to your master also. Move forward. 3 lambda by 2. What kind of position? Destructive interference. Destructive interference. Dark spot. Dark spot means intensity should be equal to 0. And see, again it will decrease and it will become 0. Again it will increase. Again it will become 400. That means this will be the difference. And that's why we watch a pattern that, okay, it is a bright spot, it is a dark spot, bright spot, dark spot, bright spot, dark spot. This kind of pattern that we have observed on the screen. Everything is connected. Is it clear? Chalo. See, here it is the pattern that have been shown to you. If we are taking the conventional rectangular slits that we have cut it, you remember I have told you very thin slits that I am going to give you, like cutting from a blade. If you are having that kind of slits, this kind of pattern you will be observing. This is a rectangular shape of fringes that you will be observing on the screen. But in case, let's suppose if you are having circular, very small circular hole, then you will be having hyperbolic fringes. Remember it. Okay. When you will be having circular slits, then you will be having what kind of pattern? Hyperbolic pattern. Hyperbola you will be knowing about in maths, basic maths. You are studying about it. Okay. So this is what you have to remember. So what will be happening if the sources are incoherent? If the sources are incoherent, still patterns will be observed. But from patterns will be made, but it will be changing very fast that you cannot observe for in fraction of seconds. Okay, it will be changing in fraction of seconds that our eyes cannot actually interpret it. Okay, so that's why we observe naturally on the screen that it is same complete white light, complete light is there on the screen. Like here, two different sources of light are coming, and here you can see there is not a proper pattern that is been made. So, and in this kind of resultant intensity, we directly define as resultant intensity is equals to I1 plus I2 in this incoherent sources. So many of the questions will be coming from coherent also only. That's I've told you that if it is a case of incoherent, then what will be happening? That's it. See, there is a basic question. Anyways, a lot of good questions are made on this, and we will be discussing all those good questions in the question series. As of now, just understand for formula understanding, take this question. See, in Young's double slit experiment, if the separation between coherent sources is halved, what is done? Separation between coherent sources. What is the separation between coherent sources? That is represented as D. Now it have been made what? It have been made D by 2. Okay, fine. It is made D by 2. And the distance of the screen from the coherent source is capital D, and that is made double. That means this capital D is made as 2D. Then the fringe width becomes, that means what will be the effect of these changes that you have made on the fringe width? What happened? Double. This capital D is made as 2D. Is there a lag? Is it clear to all of you? I think there is a lag. Please wait for 1-2 minutes. We will wait, otherwise you will miss the some portions. What happened? Tell me in the comment section. If it is fine, then we'll be moving further. I think that it is going fine. Okay, I will keep checking if there will be any lag. Until me. So the capital D we have made it equals to 2D, correct? So what will be the effect on the fringe width? Batao. Fringe width is what? What is your fringe width? That it is beta is equals to d lambda divided by d. This is what the basic fringe width. Now what you have did with the d, you have made it 2d lambda divided by what you have did with small d, it have become d by 2. That means net what you will be saying 4 times of d lambda by d. That means what have been the effect? This is what? Beta. So what I can say, beta dash is equals to 4 times of beta. That means what I can say, which option is coming correct? Third option. That means it will become 4 times of the initial. Correct? I hope that now it is very smooth. Okay. Is it clear? समझ आया? Correct. Now we will enter into the second section of wave optics. That is what the complete discussion was. Diffraction. What is diffraction? Diffraction is a phenomena of bending of light. Here it is explained by a very good example. See, let's suppose it is a person is sitting on the other. Okay, a kind of bifurcation is given, not completely, but some portion is bifurcated, and a light lamp is given current here. So light is glowing. So if light is only traveling in a straight path, I can say how much portion of the room should be enlightened. I can say, sir, if light is only traveling straight path, if light is only traveling in the straight path, that means light should become like this, and final ray should be passing like this, and light shouldn't become after this. This should be the only area that will be enlightened, and rest of the portion should be completely dark. If there is no light rays that are reaching there, then how it can be enlightened? Correct? But is it the real case? No, it is not the real case. Light will be coming on the other part of the room also. Why? Because there is the bending of light. But if we take the light as a particle, it should, if you are taking the light as a particle, it should be coming in this portion only. Why that particle will be reaching on the, if you are assuming this as a particle nature only? So that's why it was also a proof that light diffraction is also a proof that light is actually having a wave nature. See, suppose a man is sitting in a dark room. As the lamp outside the room is switched on, the room also gets illuminated as the light from the lamp spreads in all directions, because it is a wave. That's why it will be spreaded into all the directions. If it will be a particle, it will be only restricted to this portion. That's why it is a proof that diffraction also proves that light is actually a wave nature. Okay, light is actually also a wave nature. Now see, this is the definition of a diffraction: the bending of light around the corners or obstacles whose dimensions are comparable to wavelength of the light, and hence the enroachment of light into the region of geometrical shadow is called as diffraction. Geometrical shadow means what exactly? That we have shown you, that if a wave is traveling only in straight path, that means rest of the portion should be of dark but still light is coming into that, and that phenomena is called as what? Diffraction. For example, how diffraction is drawn here, and why that is coming, what is the condition? Let's understand. Diffraction only shows you when the wavelength of light is comparable of the dimension of slit. Let's suppose if the dimension of the slit here is represented as b, and if the length of this b is comparable length of the wavelength of light, then only diffraction will be happening, otherwise not. This is the mandatory condition for performing diffraction. First thing. Now how it was defined? It was also defined by the concept of wavefront. That's why I've told you that wavefront is very important. What is the case? Let's suppose from some infinite distance light are coming. From infinite distance, if lights are coming, that means what kind of wavefront it will have? Parallel lines. That means what kind of wavefront? Planar wavefronts. So these are what? These are your planar wavefronts. These are what? Planar wavefronts. If planar wavefronts are coming, that means at this point when you will be reaching at this slit, here also some wavelets will be there, some secondary wavelets will be there, and what you have understood that all these will be behaving like a new sources. That means all these points will be, let's suppose 3 points I am considering, that means all these points will be behaving like a new point sources, and they will be making their own wavefronts. And if they are making their own wavefronts, can I say light will be passing from here also perpendicular to the surface, light will be passing from here also, light will be passing from here also. So in all the directions light will be passing in all the directions. That means it is going to, if this is the screen, it is going to eliminate this much section of the screen. And if I am saying that no, light is only passing in a straight path, I think again some lag has happened.